They see in early stage they launch beta version. They do some sort of testing, okay, and then they
Okay,
get
sir.
some sort of feedback also. And if they find that there is some issue, they will revert back. So if people are complaining about such thing, they will revert back to it earlier version. Okay. I
Okay.
am using
Okay.
actually the older version of Spider. I am working for long time, so earlier one only I am using. I have not tried newer one. And Python also I am using 3.7 instead of 3.8. I think it's running 3.8 in the new Anaconda.
Yes, sir.
I'm not. No. You can install there. If you go now, then you'll find all exe file or it may be wheel file is present. You can roll back to some other version.
Okay,
Okay,
sir.
and then try it
Yes,
out. So that is small thing you can figure it out. No issue.
okay,
So what we learn here, some concept, and then you just try it out with some different data and see exactly how things are coming. Are you able to make model? Are you able to save model? Are you able to use model to predict for new instance, means for new observation? So all we are going to see in this class. And I will also show you some small app. I've just created a small app and I will show you exactly how it look like because once you train your model and if you think that your manager or people who is going to give this thing they are not able to smart like you, they are not smart like you, they don't know how to run Python and all, so you need to give some sort of interface. Actually they just punch some numbers and they get some result, correct?
yes, sir.
Usually I interact with lots of scientists, so they are not, they are good in their own field, they are not good in Python. So what I have to do is I have to give a small application so that they can use our things.
Okay, sir.
That way you can also give to your manager or your colleague who is interested to use your application. Okay, but before that, first we will build model and then we will see exactly how to save this model. So
Okay,
there are
sir.
concept of serialization and deserialization. We'll learn all this and then we'll move. Okay.
Okay, sir.
So we start now. Or I think most of you have joined it, correct? So how many? How many of you have joined? Total 28. No? So I think good time to start because already it's 7:35. I will share my screen. So it will be good if anyone will summarize exactly what we have done it in last class and where we stop. Okay. Can anyone summarize it? Where we have stopped last class? So no one looked
Yes, sir.
good again.
Sir, in the last class, we discussed about the first we discussed about the how to build the model
Mm.
by using the random forest. And first we discussed about the baseline calculating the mean, and by using that we calculated the mean square error. After that we use the features
Mm.
to and use the random forest to find out the again mean square error, and then see the what is the improvement, and then we look after the important features, we sort out the important features, and then
Mm.
we use again the random forest, and we again check the what is the mean square error.
Mm.
There is a little improvement in the
Mm.
mean square error. There we
Okay.
stop, and today we will I
Okay.
think start.
Okay, so up to most important, how to get the most important feature and use only top 5 feature to rebuild the model, and then check whether with this R is what is the root mean square error, whether it significantly decreased, improved, or what happened exactly. So we have compared up to this, correct?
Yes, sir.
So what is your name, Abhishek?
Yes, sir. Abhishek.
So you ask Abhijit to add 1 mark for you. Okay.
Okay.
I think before exam you will get 100 marks.
Yes.
Okay, good. So we'll start from there. And so I'll just rerun this code. Let me run. I'll stop it here. So as I have told you that this model accuracy depends upon lots of hyperparameters. So these are the parameters which you can tune to get your best model. So one way to do is you go and change these hyperparameters. So I will just show you for, let's say, regression model. Can you see my screen?
Yes, sir.
So if you go and see the scikit-learn ensemble random forest model, you can see there are this much. There are lots of hyperparameters. You can count it exactly how many. So number of estimator is one. Criteria is okay. MSC you can keep it. There is a max depth actually. So depth of the tree, and so how many minimum sample do you want to have it in a node to split the node, correct? And then minimum sample at leaf, then minimum weight fraction, then max feature, all those. So there are plenty of hyperparameter. If you want to go and change one by one, it will take lots of time to come up with a good model. So there are another way to do it, that's called hyperparameter tuning actually. So what you have to give it, you have to give your choice actually. Where do you want to search? What do you want? So what are the things do you want to search? Create a grid and use something called random search approach actually. To, so first of all, how to create a grid actually? Let's say you want to try different number of tree in forest. Let's say you want to try from 50 to 400 number of tree, correct? So what usually you will do, you will go and change first, go and start with 50, and then let's say you have seen some improvement in accuracy, then what you will do, again you will go and try with 100 or 150 and go and redo again and again same sets of values and see how the accuracy are improving against the improving, or it may be degrade, your model will quality will degrade also with change of these hyperparameters. Okay, we don't want to do all those things, so we are going to use something automated way of doing it, something called grid random search, randomized search approach. Okay, so this is randomized search approach we are going to. So we said that okay, n number of street, we ask them to go and try with different combination, and then it will start from 50 number of tree to 400. And to discretize it, we are saying that you use what we call equal sampling. Okay, so if you go and see that n estimator, it will create a list actually. So first it starts with 50 and 400, and total number of data point is 10. So you can count, I think it will be 10.9. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total number of distinct estimator is 10. Okay. So it will go and try with these options. And for max feature also, So we are going to try two options actually. One is auto. What is auto? If you want to see description exactly what it means, so you will go max feature. Huh? So you go, you'll find the description exactly what is max feature. So there are options. So you can choose either auto square root of log 2, okay, or you give your option actually. So if you give auto then max feature is equal to a number of feature. Basically what does it mean? All feature will be part of your tree. Are you understanding things?
Yes,
Hello?
sir. Yes, sir.
Anyone, if you have doubt, these are very important concept. If anyone have doubt, please ask. Okay. If you don't ask, then actually you will miss something, and I am going to give a project on this, so it may be difficult for you. So you have to give max features. So there are 4-5 options are there. We are going to give two options actually. Either you take all feature or you take a square root of this feature and build a tree actually. So max depth. So max depth also we want to give it actually. So we are saying that up to 10 to 110, and again number of, so total number of max depth equal to 11 actually. So you can go and run this code and see. So from 10 to 110 they are just equally sampled this and created a list for you, and I am also saying you just try with none. So what does it max? So if you can see, so max depth apart from your grid, there are another things appended in this, that is none actually. So again, if you want to go and see what does it mean, so you can go to, so an estimator, this is max depth. So max depth, the maximum depth of the tree. If none, then nodes are expanded until all leaves are pure, or until all leaves contain less than minimum sample split actually. So can anyone, based on our earlier knowledge exactly, can anyone tell me exactly what does it mean? Because all of this we have gone through when we are doing when we are learning random forest. Can anyone explain me exactly what it's trying to tell us? Just think about in classification sense actually. Just think what does it mean? All leaves are pure. Matlab means what? What does it means actually? Anyone can try?
Outcome is not dependent on features like that.
Outcomes are not dependent upon features. Okay, okay, okay. So basically, all you are correct actually. So basically, it says that uh, it belongs to same class. All observations now become to same class actually. So it is all pointing to same number, same class. Either it is dog means 0 or 1. Let's say it is binary. So all observation corresponding to all observation, your response is same. Okay, so that will say that the leaves are pure, correct? And in case of regression, what it will be? So corresponding to all this, will have same output actually. Or you can say that standard deviation is very low or 0. Okay.
Okay, sir.
So you can see that all outputs are same actually. Okay, so we have understood max depth, what is this, and then mean sample split means how many sample do you want to have to split the node. When you say that the node become a leaf, that we only learn, na? Node can become a leaf, and what condition it becomes leaf? When either it is pure or it may. So if you think that you are experiencing some overfitting, you can have like, okay, you can say that node is pure when it have less than some threshold. So number of observation less than some threshold actually. If less than 2, if less than 10 number of features comes at any node, you say that it is a leaf actually. Whether your leaf is pure or not, you don't care actually. Okay, and then bootstrap is true or false, whether you want bootstrap sampling or not. And using all those things, you have to create a random grid actually. So this is the way to club all this actually. N estimator. So you just basically what random grid, what it is doing is, it is creating a dictionary actually. Correct. You have created several choice of your different hyperparameters, and now this is the time to club all this thing together. So what you can do is to just run this and go and see what is random grid actually. So bootstrap max feature we have created. So basically we have different options to do. Okay, there is a task for you. Okay, let's say if these are our choice. Okay, there are how many hyperparameter we are going to have it? Different hyperparameters. 6, correct?
Sir.
Yes, sir.
Okay, and against each hyperparameter we have different number of choice. Let's say boost system we have side 2 actually, true and false, and max grid is have 12 different choices. Either you choose 10, then you choose 20, and max feature have two choice. Either you choose auto or square root. Similar minimum sample leaf and minimum sample split and n estimator. So there are total 6 number of choice hyperparameter we are going to have. And other thing, it is not like whatever we don't have, they are not going to have it in model actually. If you are not giving it as a hyperparameter here, what it does it will take as a default actually. So default value will consider during model building. Okay, so let's say some feature, some hyperparameter, let's say we'll go and check. So let's say minimum impurity decrease, that is, it may be that is hyperparameter, we are not considering it. So 0.0 will be a default, by default 0.0 will be considered it in our model. So you have to tell me exactly how many different combination we can create out of this hyperparameter. That is your task actually. You have to tell me how many different combination of all this you can create. So what does it mean combination? Let's say first time I will go and try with true, 10, auto 1, 2 and 50. Second I can go and try with true, 20 or true, 10, square root, 2, 5 and 88. Correct? Any different combination of all will go and try it out. So you have to tell me how many different combination you can make out of this.
4320.
How much?
4320.
How did you do it? Can you explain?
Multiply
Or leave it for today. What we'll do, we'll come up with this in next class. We'll give a chance to other also to think. Okay. So basically from this actually we can think it, there were lots of parameters they have to go and test it, and it will take lots of time. To avoid this, we are going to use something called randomized search. So it will not go and check each and every point. So what it will do, randomly it will create a combination of your all parameters. Okay, and then, and what does it combination, I have told you actually. So they will go and create a combination of this and go and not go and one choice is go and check each and every point and see that what is the accuracy you are getting. Correct? Other point it will go and randomly search some of the point and do this and see that how much accuracy it is coming. And out of this, whichever best is coming, that will call it best hyperparameters. I will tell you one more thing. Another way is you first go and do random search. Get some hyperparameter out of it, best hyperparameter out of it, and there is another hyperparameter approach that is called grid search. Then what you do, you take that hyperparameter and look near to that hyperparameter and see whether you are able to improve your accuracy or not. Understood or not? Or I will explain it again. Understood?
Yes, sir.
Okay, so what I will do, I will just run this and we will see. It will take some time. So if you have any doubt, you let me know. So it is just see actually. We have just created a grid. We have given estimator is equal to RF for tuning. Okay. Can you run your code and check whether are you getting any error?
Okay, sir.
You just check, because I have made lots of changes. I don't know from where it is coming. I have to check from where it is coming actually. I am getting some sorts of error. Where it is actually feeder transform and feed param actually. Are you running? Are you people running it? It says some version issue. Are you running that one code?
Yes, yes, sir.
Is it running or are you getting some error?
No, it's still running, sir.
Okay, let me check. Let me know.
Okay, sir.
So who are all trying this? I will ask you people to show your computers or laptop. Once it run, now let me know. Okay.
Okay, sir.
Yeah. And if you get error, then I will modify code. Otherwise, I will not modify code.
Okay, sir.
Okay.
No error, sir.
Okay. So can you share your screen and tell me what is the root mean square error?
Okay, sir. Mm. Sir, it is 1185. Best one.
So, so can you share your screen?
Okay. Sir, I shared.
Okay. Okay.
1185 is the best one.
1185. So some improvement you got it when you are using based hyperparameter, correct?
Yes, sir.
Okay, good. So how many of you are able to run this code? Rajnikant,
Yes, sir.
are you able to run this code?
Yes, sir. I'm getting 1187.55.
That is okay, no issue actually. Okay, so what we are going to do now, I will tell you exactly how to save your model. That concept is called serialization. Let me share your. So how many model we have built actually? How many model we have built? So we have built at least 3 model, correct? And one model, base model, that's not exactly you can say model, but that so total 4 model we have used. 3 random forest model, one with uh, just with default parameter, another with most what you call most important top 5 most important parameter, another with the best parameter using grid search, correct? We have used all this, and now let's say we want to use our model for future use, means we have to use pre-trained model. Already we have trained our model, now we have to save our model and use it for predicting new instances, correct or not? Can you see from line number, let me see. So to make prediction exactly, what are the thing do you need? Tell me. To
Features.
make prediction, what are the thing you have to you need it? One is you need model, correct? Second, we need
Features.
scalar,
And
which we have used to scale the data, because when we give data to model, that time data was scaled, correct or not?
Yes. Yes, sir.
If anyone will give me data, they will give me in original form, not in the scaled form. We have to scale the data to give to the model, correct?
Yes, sir.
And you can also think a person can give data in any order actually, but we have to use data in the way we have used it in the model, correct? Same order we have to use.
Yes, sir.
So that information also we have to save. So these two information we have to save along with model. So first of all, you have to go and create a dictionary. So what we are saying is, okay, so first let's say model info. First you have to import another library called pickle. This one, line number by 22. Can you see line number 22? Import pickle. This is same pickle what we eat every day. Okay, now line number 2. Have you imported pickle in your file?
Yes, sir.
Okay. And then we want to save these two information in a dictionary. So just create a empty dictionary, model info, and just open and close the braces. So that is nothing but you are just creating a empty dictionary. And then we start giving a values and key for every whatever we want to save. So shall we go down? Are you able to write it?
Yes.
Model underscore info, and then just pickle file you have to do it. Then so model info we want to put features. Feature is nothing but a list actually. You can see this is the way we have created a model. Okay, this is the feature order we have used it in model. So HP was first, then automatic, mid color, fuel. Okay, so model feature and model feature is scalar. So basically scalar is nothing but an object which we are using to scale the data, correct? You just see scalar dot transform train x. So whatever incoming input we have, first of all we have to put it in order and then we have to scale them. And then you have to save model. So first of all you have to save model. Actually, where do you want to save? You have to give a path. Actually, we want to save it in result path. So result path plus you have to give that name of the model. So I am giving RF model is nothing but random forest model, and format you have to give. So you have to give either .pickle file or .sav. So I am giving here .sav. Okay, and another is model info file name. So these two also we want to save it. So this we are giving a file name RF model info. Info is nothing but the information short form. So random forest information, and just we are using pickle.dump. Then you have to give which one you want to dump. I'm saying RF. RF is nothing but our first model. Actually RF is, see this RF line number 112 is nothing but our first model actually with the default parameter. You can also save your base model with base hyperparameter. That also you can save actually and compare result exactly how the prediction are changing. I'm just doing saving first model actually. Out of 4 model, for second model actually I am saving it. That is first random forest model. And then you have to open it and give the file name, which is nothing but model file name, and write. You have to give WB means write. Here again you have to save that model info, and again you have to give the model file name, info file name, and then this. Once you do it, run it, you will save. Two file will get created into result file. You can see now. Can you see this? Let me know once you are able to do it. Anyone able to do it? Able to save model and then information?
Sir, we have to write all these things because in our code we don't have this, the last part.
Yeah, you have to write it. Correct. Just copy paste and check. copy paste and check it. So can you see my screen now?
Yes, sir.
Yes, sir.
Okay. So basically we have dumped these two files. So it is like our pre-trained model, and we have to utilize this model to make prediction for new instances. Like if someone is coming to sell their another car, we have to quote price. What will be the price? So let me know once you are able to do it.
Okay, sir.
Then we will move to make another function which is called predictor.py. Anyone able to complete it?
Thank you, sir.
Completed?
Yes, sir.
So are you able to see these two files in result folder?
Yes, sir.
rfmodelinfo.sab and rfmodel.sab.
Yes. Yes, sir.
Okay, so what we are going to do is we are going to create a predictor function. Okay, that's very simple actually. What it will do is it will take all of your information as a data frame, and then whatever information you have saved, like how to scale this, and then model information, you just make a function name is predict resale values. So how this data will come actually, they will give you data, but what we have done is we have converted fuel, which was a string, into a numeric values, correct? So there were two features get created, something called fuel type diesel or fuel type petrol.
Yes, sir.
Understanding or not? So someone will give you data, so you have to convert that data into a data frame, pass this into this function. First argument will be your data frame, and then second will be your model information, and then model, correct? Sorry, model means your model and model information. So people will give you that what type of fuel vehicle it is, whether it is CNG, diesel or petrol. So we know that these two features get created. So just what we have to do, we have to create this DF, these two features, and assign them to a value 0. And then we say that if fuel type equal to petrol, then you assign that value to 1. And if fuel type equal to diesel, then assign it with 1. Okay. So if it is petrol, then you assign it to 1. If it is diesel, then you assign it to 1. Otherwise, 0, 0. By default, if it is CNG, then automatically it will be 0, 0. Correct? Because by default value is 0.
Yes.
And then just we are converting data type conversion. Just we are saying that convert all this feature into a float. And then what we are saying that you scale this data. So we are see this, we are getting this scalar, and then dot transform df. The way we have converted our data frame during the model building, scale the data during model building, same way we are scaling here also. Same scalar we are using. And then what we are saying that predict value is equal to pre-trained model dot predict scaled values, and that will create a list actually. And then we are saying that, sorry, an array, we are saying that you just take out the first value and return me that values. Okay, so this is predictor function. You have to write it like this. So for any data set, whichever you get, you have to think actually what are the things you have done during model building. And if people will give me new data to predict, how I am going to do this? You have to think steps and then make a predictor function. Okay, and then come to place where you have to predict it. Okay, so what we have to do here, first you have to load all your, first you have to import OS and then load your, give path to all your directory whichever you have created, and then you have to load this predict function. I hope during that last Python class you have all this thing, you know all those things actually, how to load function from directory and all, because you have already one semester Python course.
Yes, sir.
Then you have to load your model also. So first you have to give path name and then you have to just load your model like this. And then what you have to give for, let's say, new vehicle, we want to predict it, what will be my resale values. So I'll just go and run this. We'll see what will be my resale value. It's saying 15,967. Okay. So basically car feature, see this is the way, let's say people is they will give you some numbers. Let's say they will say what will be the age of my car, how much my car run already, what will be horsepower. All this information you have to put it in dictionary. Then you have to use this dictionary to create data frame, and then you have to use this function whatever you have made, predict resale values, to predict the car price, resale price of the car. How many of you understood? How many of you have not understood this? Shall I explain it again, or you have understood this?
Sir, yes, sir. Explain it again.
Okay. So first, what you need to import your library whichever you need. So I am using data frame, so I have to use pandas, because data frame is a method or class inside panda, and I have to use pickle because pickle is used to save the model, and then I am going to load that model. So pre-trained model I am going to use to predict it, and import OS is because we are going to interact with our this directory where we have saved our model and then required information. So these are all this file actually, and we have made a function to predict the resale values, and that function is inside the API folder. You can go to API folder and then predictor.py is inside that. So we have to, from this file we are going to call this function predict resale values. That's all we are doing up to line 15. Line 21 to 22 we are going to give the path where we have saved the model. If you don't give path, it does not know from where to load this model. So this is the path where we have saved the model. Then this is the pickle.load. Last time we have used pickle.dump to dump the model. Now we are going to use pickle.load to load that file. And then we are going to have a dictionary actually. Dictionary is easy to understand because you can give key as a feature name and values for that values actually. And then you have to just convert this into a data frame. Same thing we are using actually, car.feature.value and list of car.feature.keys. That is nothing but a column name. So you can see car feature df, car feature, you can go and check what is car feature df. So you can see this age, kilometer, 19, all this. And then we are just using our predict function to predict it, and I am just printing this result. That's all we are doing. I think this is easy only. If you do it, if you try to do it, this you will also find it easy only. We are not doing any the very high funded stuff here. We are doing a small thing, but nicely we are doing. First, what we have done, we have pre-trained our model, saved it, and now utilizing that model to make prediction. Okay,
Yes. Yes, sir.
that is good to go. But what is issue with this actually? Tell me. Even though I had made very simple function, people can get scared actually while looking all those things actually. We are smart people, will not get scared, but if you any other people who does not know Python, they'll say, oh, what is this is very hard, you will not use that application. Since you have given lots of effort to develop your model, you want people to use it. Okay, so we will not give them Python. So people does not need to know Python and all, but we'll give them a very, what you call, easy interface. I will show you. So there is something called Streamlit to create this small web-based application. So we don't have to host it in cloud. So we'll use our computer itself to make a server and then run this. So very easy actually to create interface through Streamlit. Just think actually how many lines I have used to create a interface. Just see from line 1 to line 54, that 53 means only 50 lines of code and lots of things. Just it is very simple actually. I will show you app actually. Let me see whether it is running somewhere. If it is not running, I have to start server. So to use this now, you have to install actually Streamlit. Okay, I have installed it in one what you call container, and from there I am going to call it. But it is very easy. You have to just install. If you are using your own laptop, not just pip install in Streamlit, it will get installed. I am not using my laptop actually. I am using Pfizer laptop. So that lots of rule and regulations are there. So for every project actually we have to create something called virtual environment and we have to work actually. Okay, so what we have to do, we have to get path this. And then you have to go to app path and then you have to call your Python program. Just a minute. So you can see that app is now running actually on local host in my machine itself. Can you see the screen, my screen?
Yes, sir.
Okay. So you can now see people does not know exactly what we have done. We are not going to use Python actually anymore. People will not see my Python code and all. What they can see that this interface only. So what we have to do is we have to go and select what is the fuel. So there are how many fuel types do we had? Remember?
Sir, our interface is not visible.
Interface is not visible.
No, sir.
Okay. Okay. Let me share it. Just a minute. I'll redo it. Then I think it will be visible. Sorry, by mistake actually. Just can you see now?
Yes, sir.
Okay, very good.
Yes, sir.
Very good. So now actually with only 50 lines of code we have made a very quick, within half an hour we have made this app actually. Very easy to do using Streamlit. Okay. So you have to give option to select what are the fuel types we had. Okay, correct. This was the way data was. So what was option? Petrol, diesel and CNG, correct?
Yes, sir.
And then whether it was metallic color or not. This was okay. Let's say then there were car weight actually, car CC, car age was there. Then number of door, kilometer run, whether car was automatic or like manual, and then HP, and then you have to predict it. Can you see now?
Yes, sir.
Good. So you can go and change things and see exactly how things are changing. Let's say instead of 50,000, I'll say 30,000, and then I will go and age of car also. Let's say I'll change it to some 20 month, and I'll see exactly how it will come and predict it. Okay.
Yes.
So this is the way you can give it to your friends or colleague who does not know Python much. Okay. And if you see
Yes,
that
sir.
Streamlit code, that's very easy actually. This is the code actually. This is code, and see what we are doing. Again, we are reloading model. Nothing new actually we are doing. We are just same thing the way we are doing it here, resale prediction, same way we are doing here also. See, imported all this file. Before that actually we have imported Streamlit because that is the platform we are going to develop a app, and then like import pandas for reading our data frame, because my predict function actually we are using predict function to predict only. So predict function take data frame, so we have to pass input as a data frame also. If you give another data frame, it will go and fail actually. So lots of things you have to do. If you want to make good application, you have to do it. Okay, so this is header, and then we have given this card attribute, and then just imported few library whichever we needed. So 2 times actually we have imported, we don't need. Then pickle we have used imported because we have to deserialize our uh, pre-trained model, and then OS to interface with my files and directories. So all this, and then I have made a image folder actually to save this car image, whatever you are saying now. So this is going to be static actually. So this is just car image, what you are saying is, that's all. So we have to create image folder and then load that image file. Then you have to load model. This is very simple thing already we have seen, and just create a small function actually to get all this feature actually. So fuel is nothing but sidebar. Sidebar means left hand side it will go and create what type of things do you want to create actually. So we have given a drop down and choice was petrol, diesel and CNG because these are the choice for my fuel. Then car color, this was also a drop down. So select box is nothing but your drop down. So 1 and 0 you can see car weight. Car weight was like your uh, numeric numbers actually. So 12 means, and you also have to give default values. Otherwise what will happen if anyone without entering numbers, punching number, if they press predict, then it will give error because there's no number, and if it is not a number it will consider as a string and then it will complain actually. Your app will complain. Can can you see my screen?
Yes, sir.
Okay. Likewise, for other input based on that whether it is numeric or categorical, you just have to create it, and then once it get created, you just collect all this information based on the variable you have defined it. So fuel type we have created based on variables we have defined fuel underscore. Like that you just create dictionary and then you just convert it into data frame and then call this function. You will get data frame and then this is just image and image path, that's all. And then if sidebar dot predict button, if it is predict means if you press, then it will call this function and then it success, and my resale values is, it will say that whatever resale value you have. Okay, nice. Understood? Hello? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Yes, boss. I think only you are other. I think others are sleeping now. What happened to others? Rajnikant.
Yes, sir.
What happened to you? You're not. Is it very hard to understand?
No, sir. No, sir.
It is not hard actually. It is very easy to understand. It may be first time it may you will feel difficult, but very easy to understand and doable. See, up to predict function you are doing it. Anyway, you have to serialize your model to make prediction. Correct? Because you cannot use your same script actually to make prediction. Again, otherwise, every time it will give you new prediction. Once you say that, okay, my models are good enough to get deployed, you have to save that model. So anyway, you have to make predict function to make prediction, and this is the another additional effort, a small effort only to get this visualization. That's all. Get this interface. That's all we are doing here. So I think now the time to do something actually. If you have understood this code, I will give you 15-minute times next class. You have to tell me exactly what problem you are facing with this code, or if you have any queries regarding model building, you can ask me, and then we will move to another topic, which is support vector regression.
Okay, sir.
Okay.
Okay, sir.
Okay, sir.
So
Okay, sir.
coming next class, whatever doubt you have to tell me, and then we will move to another topic. That is support vector regression. I think I've given you enough time to understand this code, to understand model building procedure. Then you have to work and see exactly how things are. You can also visualize tree. You have grown lot more tree. Now see, you have tried it out from 50 to 400. You also see your hyperparameter exactly how much number of trees come out as a base n estimator. If you want to see any tree, you have any decision tree, you can see it. So you have to install another module. Okay, you have to find it out. I think you have to take some, you just search how to visualize tree in random forest. Okay, that is very easy to do it. You have to you have to just install another module and you can visualize. Then try to understand exactly what we have learned through the class. Is it theory matching with practice or not? Tree which you have grown is matching with or not? Okay, and then I will tell you exactly what you have to do for your assignment, and then I will give you 1 week or 2 weeks of time, and then you have to submit all your assignment, and it contains 5 marks. So Abhijit, I think you are just noting it down who is answering in this class, and then making a note out of it and crediting numbers accordingly. Abhijit is here? No. Hey Abhijit, are you in meeting? Okay guys, so I will let you know exactly what you need to do in assignment.
Okay, sir.
And mostly it is not going to be theoretical, because at the end from the data you have to get the model or insight from the data. So mostly it is going to be hands-on only. You have to create some sort of model and then share with us. Okay. Okay guys, bye, good night. We'll meet on Thursday.
Okay, sir.
Bye.
Thank you, sir.
Good night.